Okay, 8th graders, today we're talking about exponential functions, and your essential question is, can you identify the characteristics of an exponential function? So we first here have a graph that shows estimates of the population on Earth from 5000 BC through 1500 AD, and it's shown at 500-year intervals. So we want to describe the pattern. So if you take a look at the graph, it's increasing, obviously, and it's increasing in a curve. So for our description, we can just say that the graph curves upward. Letter B. Did the Earth's population increase by the same amount or the same percent for each 500-year period? So, it obviously didn't increase by the same amount every 500-year period, because if it did that, it would be a straight line, increasing by the same amount each time. It would go in a straight line upward, so it has to be the same percent. Okay, let's talk about what an exponential function actually is. It's a function in the form y equals a times b to the x power. So this is what you need to know. Go ahead and turn your paper. We're going to practice using some or writing some exponential functions, or identifying some exponential functions first. Does each table represent a linear or an exponential function? And explain. This is supposed to be a table, but I forgot to draw the lines in. So, our x values increase by 1 each time, and our y values increase by 2 each time. So there's a constant rate of change here. So the function is linear. On our exponential, let's see if this one is an exponential function. We increase by 1 each time. And then here we have plus 4, plus 8, plus 16, or times 2, times 2, times 2. So when you have a linear function, you're going to have an addition that stays the same. When you have an exponential function, you're going to have a multiplication pattern that stays the same. So, sorry. So this is an exponential function. My camera's top heavy. Okay, number 2, evaluate each function for the given value of x. So x in this case is our exponent, and I'm filling in 3 as my exponent. So on this one I have negative 2 times 5 to the 3rd power. And if I do negative 2 times 5 to the 3rd power, I get negative 250. And then here I'm filling in negative 2 as my exponent, so 3 times 0.5 to the negative 2nd power gives me 12. next set of problems, we're going to sketch the graph of each exponential function. And so the first thing you're going to want to do is make a table. So here's my XY table. If I fill in -2, 2 to the negative second power would be 1 over 2 to the second power, which is 1/4. 2 to the negative first power would be 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. So if we graph that, graphing these will be the easiest. 2 to 2, 4 is here. 1, 2, 0, 1, -1, 1/2, -2, 1/4. So your line is curving upward that way. So again, let's create a table. I'll make it out here this time. -2, -1, 0, 1, 2. On exponential functions, you're going to want to do 5 points instead of our normal 3 points. Because if you only do 3 points, this could end up looking kind of like a line. When you do 5 points, you can see really clearly that it's not a straight line. So 2 times 3 to the negative second power gives us 2/9. 2 times 3 to the negative first power gives us 2/3. 2 times 3 to the 0 power would just be 2, because it would be 2 times 1. 2 times 3 to the first power would be 2 times 3, which is 6. 2 times 3 to the second power would be 2 times 9, which is 18. So -2, 2/9, -1, 2/3, 0, 2, 1, 6, and so on. I can't even graph 2/18. Okay, 2 to the x power plus 3. So we do -1, 0, 1, 2. Oh, I forgot my -2. Okay, 2 to the negative first would be 1/2 plus 3 is 3 and 1/2. 2 to the 0 power is 1 plus 3 is 4. 2 to the first power is 2 plus 3 is 5. 2 to the second power is 4 plus 3 is 7. So -1, 1, 2, 3.5, 0, 4, 1, 5, 2, 7. So again, we have this curved line. And this one's not going down on the x-axis, but it is going to flatten out down here. Okay. I have 7 problems for you to do for homework that are exponential functions. On the first 4, you're filling in x and finding the answer. That's it. Just type it in your calculator. On 5 and 6, you're going to graph the function. And tell me about the domain and the range. What do you notice about them? On number 7, it's a word problem, but it gives you the equation here. So you should be able to do this one pretty easily. Okay, have a great night.